Shebby, which fact should you use?
Fact A.
Fact A, okay, so using fact A, he should not shoot. All right? Alternatively, he could think that Patrick's going to shoot tomorrow. Is that right? He could think Patrick's going to shoot tomorrow. If he thinks Patrick's going to shoot tomorrow, which fact should he use?
B.
B. He should use fact B, in which case he has to look at this inequality up here. Let's look at this inequality and say, I'll shoot if my probability of hitting now plus his probability of hitting tomorrow is bigger than 1. Well, let's have a look. This is Patrick's probability of hitting today, and this is Shebby's probability of this is Shebby's probability of hitting today, and this is Patrick's probability of hitting tomorrow. And is the sum of them bigger than 1 or not? Is it bigger than 1 or not? It's not bigger than 1. So what should Shebby do? He should step, right? He should step. All right? So he'd step. All right? He'd step. All right? Now it's Patrick's turn. All right? And once again, imagine this distance is still pretty large, and there's two things Patrick could think. Patrick could think that Shebby's that Shebby's not going to shoot tomorrow. Right? So here's Patrick. He's looking forward to Shebby tomorrow, and he could think that Shebby's not going to shoot tomorrow. If he thinks Shebby's not going to shoot tomorrow, which fact should he use?
A.
Should use fact A, okay? And if he's using fact A, he should not shoot. Right? Alternatively, he could think that Shebby is going to shoot tomorrow, in which case he uses fact
B.
B. All right? And what does he do? He adds up his probability, Patrick's probability of hitting today, plus Shebby's probability of hitting tomorrow. He asks, is that sum bigger than 1? And he concludes no. So we have no shot here and no shot here. And notice that both of those arguments were dominance arguments. In each case, whether Shebby thought that Patrick was going to shoot tomorrow or not, in either case, he concluded he should not shoot today. Right? And when it was Patrick's turn, whether Patrick thought that Shebby was going to shoot tomorrow or not, in either case, he concluded he should not shoot today, so he takes a step forward. All right? And this argument continues. It'll be Shebby's turn next, and once again, he'll look at these two possibilities. If he thinks Patrick's not shooting tomorrow, he wants to step. If he thinks Patrick is going to shoot tomorrow, he's again going to want to step the way it's drawn. And once again, we'll conclude step. All right? And we'll go on doing this argument, and everyone see that in each case, this dominance argument will apply. It won't matter whether I think you should shoot tomorrow or not. In either case, it'll turn out that I should step forward, whether fact A applies or whether fact B applies. All right? So we'll go on going forward, and we'll have no shot, no shot, no shot, no shot, no shot, and we'll arrive at D star. Okay, 2, 1, 2, 1, 2, 2, 1, 2, 1, 2, 1. All right, so it turns out that D star is going to be Shebby's turn again. All right, and at D star, we try exactly the same reasoning. At D star, he says, if I think Patrick is not going to shoot tomorrow, what should I do? What should I do if I think Patrick's not going to shoot tomorrow?
Not shoot.
Not shoot. But now something different occurs. Now he says, if I think Patrick is going to shoot tomorrow, then when I look at my inequality up there, my star inequality, and add up my probability of hitting today, which is this line here, plus Patrick's probability of hitting tomorrow, which is this line here, suddenly he finds it is bigger than 1. Right? He finds it is bigger than 1. So now, if Shebby thinks that Patrick is going to shoot tomorrow, what should Shebby do?
I should shoot.
He should shoot. All right, so up until this point, a dominance argument has told us no one should shoot. But suddenly, we have a dilemma. The dilemma is, if Shebby thinks Patrick's not shooting, he should step, and if Shebby thinks Patrick is shooting, he should shoot. Everyone with me so far? So what have we shown so far? We've shown that no one should shoot until D star, but we're stuck, because we don't know what to do at D star, because we don't know what Shebby should believe at D star. We don't know whether Shebby should believe that Patrick's going to shoot, or whether Shebby should believe that Patrick's not going to shoot. So how do we figure out what Shebby should believe Patrick's going to do? What? Wait. Wake up the guy in orange there. Right? The guy with the ginger hair, that's right. Yeah. What's the answer to that question? Good. The answer to the question is backward induction, right? Good. Round of applause for remembering the answer. All right, good. Backward induction is the answer to all questions, especially when you're asleep, right? Okay, so now we're going to use backward induction. But where does backward induction start here? Backward induction starts at the back of the game, and what's the back of the game here? The back of the game is where? It's when these two guys, neither of them have thrown their sponge, and they've reached here. All right, so come in a second. Step. All right, and let's assume it's Patrick's turn, and they're absurdly close. They're uncomfortably close. All right, if they had longer noses, they'd be touching, right? They're at distance 0. They're at distance 0. And at distance 0, at d equals 0, let's suppose it's Patrick's turn, right? So at d equals 0, no one is shot. It's Patrick's turn. He's got the sponge. What should Patrick do? Shout it out, Patrick.
I should shoot.
You should shoot. Patrick should shoot, right? At d equals 0, say it's 2's turn. And the answer is he should shoot because the probability of hitting at distance 0 is 1. All right, let's just move you to the side a bit so that people can see the board. So I know it's an awkward dance, but here you are, right? Right, stop there. That's good. Okay, so at distance 0, they should certainly shoot. All right, so now let's go back a step in the backward induction. So at distance 1, so just take a step back. All right, so take a step back. It's Cheby's turn at distance 1. So it's Cheby's turn. And what does Cheby know? What does Cheby know at distance 1? Cheby, what do you know? Shout it out.
That Patrick will shoot next turn.
Right, so now Cheby knows that Patrick's going to shoot tomorrow. So which fact should Cheby use in deciding whether he should shoot today?
B.
He should use fact B, and that tells us, right, so 1 knows that 2 will shoot tomorrow. So, by B, 1 should shoot if his probability of hitting at distance 1 plus Patrick's probability of hitting at distance 0, if that is bigger than 1. Well, is it bigger than 1? All right, let's have a look. We had a shot in here already. We put a shot in here. And we're looking at distance 1, all right? And so we're looking at this distance here plus this distance here. And is it bigger than 1? Yeah, it's bigger than 1. Here's a bit more math. I lied to you before. 1 plus something is bigger than 1, okay? All right, so this is bigger than 1, so shoot. Let's put it on our chart as shoot. All right? Let's go back a step. Sorry, I have to have Cheby go all going backwards. Right, now we're at distance what? We're at distance 2. We're at d equals 2. And it's Patrick's turn. 2's turn. And what does Patrick know? Shout it out, Patrick.
I know that Cheby's going to shoot next turn.
Right, Patrick knows that Cheby's going to shoot next turn, so Patrick therefore should use which fact?
Fact B.
Fact B. And fact B tells him that he should, let's put this in, so 2 knows that 1 will shoot tomorrow, so by B, it's all the same thing, we know that 2 should shoot if P2 of 2 plus P1 of 1 is bigger than 1. But if we look at it on the board, here we are, it's 2's turn. He's looking at this distance plus this distance. And is it bigger than 1? It is bigger than 1, so he should shoot. And we can go on doing this argument backwards. We'll find that Cheby should shoot here, because this plus this is bigger than 1. And we'll know that here, Patrick, once again, will know that Cheby's going to shoot tomorrow, so he should use fact B. So he should shoot, provided this plus this is bigger than 1, but it is. And now we're back at D star. And the question we had at D star, the question we'd left hanging at B star was what? At D star, we knew already that Cheby would not shoot if he thought Patrick was not going to shoot tomorrow, but he should shoot if he thinks Patrick is going to shoot tomorrow. But what does Cheby know at D star?
I know Patrick's going to shoot.
He knows Patrick's going to shoot, so he should shoot. That right? He knows Patrick's going to shoot by backward induction, so he should shoot. So we just solved it. What did we actually show? We showed, have seats, gentlemen, sorry to keep you up here. Right? We know that prior to D star, no one will shoot, so not shoot. And we know that at D star, and in fact at any point further on, we should shoot. That's horrible writing, but it says shoot. All right? So we've shown more than we claimed. We claimed that the first shot should occur at D star, but we've actually shown more than that. We've shown that even if you went beyond D star, and if somebody had forgotten to shoot at D star, at least you should shoot now. And give me like 2 more minutes or 3 more minutes to finish this up, because we're at a high point now, okay? All right, everyone okay to wait a couple of minutes? Okay. So what do we prove here? We proved that the first shot occurs at D star, whoever's turn it is at D star, whoever's turn it is at D star. It wasn't that the best guy, the better shot, should shoot first, or the worst shot should shoot first. It turned out that given their abilities, there was a critical distance at which they should shoot. Right? If you go back to the 18th century military strategy, you should shoot when you see the whites of their eyes, which is at D star. All right? All right? But we learned something else on the way. I claim we learned that if you're patient and you go through things carefully, that the arguments we've learned in the course so far, dominance arguments and backward induction arguments, can solve out a really quite hard problem. This was hard. Right? It would have been useful for the guy in War and Peace or in Jagen or the guys cycling in the Tour de France or you guys for your sponges to know this, and we can solve this exactly using backward induction. And everyone in the room can do it. Let me just push the argument a tiny bit further. One thing we've always asked in this class is, okay, that's fine if everyone knows what's going on in the game. Here we have our smart Yale football players, and they know how to play this game, so they're going to shoot at the right time. But what happens if instead of playing another smart Yale football player, they're playing some uneducated